Okay, so today is reviewing again for the final and for the first semester, and we're in the complex numbers review right now. We're going to do D as in donkey. It's a little more complicated than this one. That would have been really easy. It would have been negative, and then the square root of 169 is 13, so it would have been negative 13, right? No. Negative underneath the square root doesn't mean negative. It means the answer will have a what in it? An I. Very good. It's because the square root of negative 1 and the square root of 169 are your two parts, and that's I, and that's 13, and so we say 13I. But D is much more complicated because I got to break it up into three square roots. Square root of negative 1, which is I, and who knows what to break up 48 into? 16 times what? Ooh, that's a tricky one. Not many people would have had that one just right off the tip of their tongue. So then, could I leave it that way? No. What's the square root of negative 1? I. What's the square root of 16? 4. And then it's I4, or 4I, yes, technically 4I looks a little better. Square root 3. There we go.
How come you don't need the plus and minus?
Good question. If the problem had a plus and minus on the outside, like this, or like the quadratic formula has, then you need a plus and minus. But there's no requirement that in math these are always plus and minus. It's just because of the quadratic formula that we often end up with plus and minus in front of them. But square roots can just be that can be just a square root of 9, and that's just 3. It is not plus and minus of the answer. The only reason that comes in is when you have quadratic formula or some other kind of equation. All right, so like this one where the negative's on the outside, is there I involved at all? Nope. It's just negative whatever the answer would be. And then we can break up 72. Ooh, I like that one. 36 and 2. I wouldn't have thought of that one. I would have probably gone with 9 times 8. But the problem with that would have been that this would have been 3 root 8, and then it would have looked like it was done, but it wouldn't have been done because 8 could have been split up into 4 and 2. But I like your 36 times 2 thing because then it'll just jump right to the answer. Negative, what? 6 root 2. Okay, good. Why don't you do H as in hamburger? I don't know if you've seen the movie I'm referencing there. That would be the Pink Panther. Steve Martin. It's awesome. Okay, another thing you got to know from I's is that I squared means something special. What is it? I squared is negative 1. So when they have all of these, you're supposed to be breaking them up into a bunch of I squareds because I squareds are negative 1. So like, for instance, this I to the 4th, that's I squared times I squared. And what is each of those I squareds? Negative 1. So it's really negative 1 times negative 1, which makes what? Positive 1. All right, why don't you do this one and this one? And just a reminder, if you have a leftover I, just plain old I, then it's an I. Not everything has to be an I squared. This will have an I squared, but it'll have more than just an I squared. Eventually, you got to get a bunch of pieces together to make I to the 5th, and hopefully you'll be able to figure out, oh yeah, it's a negative 1 and a negative 1 and an I, and then I multiply it all together, and yes?
When you say like to explain this one, are you referring to?
Yes. So when the ones I've already done, those are part of your homework, but also the ones that I circle and say, you should do this, but I'm not actually doing them, I want you to do all the ones I circled up here, which are K, and I already did L, and then M, and then N. Those shouldn't take you very long if you know what I squared is. And you can break up into I squared times I squared, etc. You with me? Okay, good. On to number 2. Problem 2. Clear my ink. Computer's running really slow. I don't know what's going on. Hold on. There we go. Okay. So, oh my gosh, I got a graph. Yes, again, graphing should actually be your happy place because you have XY charts to graph with. You can do vertex form and find the vertex and then graph it. There's so many ways you can graph, but my favorite, and I know it's not always yours, but I put it on the top 20 to make you realize you can solve anything by just sticking in numbers for X and seeing what comes out. So let's look at this one and see the XY method. So pick a number, any number. We'll stick it in for X. Okay, 4 is pretty big. 4 squared is 16 plus 2 times 4 is 8. 16 plus 8 is 24 plus 5 is 29. Where 29 is on the graph, it just doesn't fit on my graph. So how about we pick any small number? How about 0? I like 0. 1 would work too. I'll do that in a minute. So 0 would be much easier. 0 cancels that, and then the answer is what? 0, 5. So you just go over 0, up 5. Boom. That has to be 1, 2, 3, 4, 5. That has to be on my graph. Now, it's not necessarily the vertex or anything special, but it's just a spot that's on the graph. And then let's stick in 1. 1 squared is 1. 2 times 1 is 2 plus 5. Put it all together. You got 5, 6, 7, 8. Did you get 1, 8? Okay. So I go over 1, up 8. Now, with only 2 dots, you can't tell where that parabola is yet. I know it's a U shape, but I don't know exactly where it's going to keep going to. So I better try some more numbers. Give me something else to put in. -1. -1 goes in here, and I get -1 squared, which is 1. 2 times -1, -2. What does 1 and -2 and 5 make when you put it all together? What's 5 and the -2 make when you put them together? 3. And then a +1 makes 4. -1 comma 4 is on my graph. -1 comma 4. All right. Ooh, it just turned. See how it went over 1, up 1 from that one point? I bet you that was the vertex right there. Okay, so I bet you if I go to -2, I'll have the parabola start to show up. I'm putting -2 squared is 4. -2 goes in here, and I have 2 times -2. And this makes -4. +4, they cancel, and I get 5. -2 comma 5. Yep, it just made the turn. See how that's a parabola? Now you see where the vertex is and stuff. Now, there's better ways to do this, but this way always works. That's something really good in math, is you can find a way that always will work. All your graphing problems, every one of them, you can just stick a number in until you find enough points, and you'll see where the turn is and stuff. All right, next thing. Could I have done half and square thing on this to find the vertex? Yep, let me show you real quick. I move that 5 over, and then I have this. What's half of 2 squared? 1. If I go +1 and -1, this part factors x plus 1 squared, and this part right here is the remainder, and it's +4. That tells me -1, 4 is my vertex. And there it is. There's the vertex, see? So finding vertex form is another great way to graph. Once you get it in vertex form, you know the vertex, which is like the main point. And from there, you can just follow the little pattern. Over 1, up 1. Over 2, up 4, etc. Okay, so this one's in vertex form. So that one I want you to do, and it'll be super easy because you already know the vertex. Is there a stretch factor on this one? Nope, because there's no number in front. So therefore, don't have to worry about stretches. So you just follow the little pattern once you've got the vertex. Could you have done the XY chart? Sure. Want to do that? Go ahead. It always works. Yes?
What are you rating the solutions?
Good question. It's where it touches the x-axis. Judging by this parabola here, where is it going to touch the x-axis? Never, and therefore none.
Okay.
I know that's a weird answer, but isn't there times when there's no real solutions? And therefore there would be imaginaries, okay? Let's see. I don't think we'd make you find the solutions on this type of question, because at this point, wait a minute, now that I think about it, this is on the worksheet called complex numbers. So yeah, you can find the solutions without having the graph by doing the what? Quadratic formula. My bad. I won't make you do both of these, but would you find these solutions then by doing the quadratic formula? X equals -b plus or minus square root b squared minus 4. You see, over 2a. Yeah, I just realized. I mean, there are no real solutions, but the whole worksheet's called complex numbers, implying you can get the solutions as long as you use imaginaries. So, yeah, your answer, of course, then has a square root of a negative in it, and all right, I'll let you finish that. So why don't you do this one, just the graph only. You don't have to do my solutions for that one. And The other one, I would like you to do the solutions. It's just a quadratic formula, and if you're scared of that, you should practice it because it's your friend. It's quadratic formula is cool because it always works. All right, now there's a whole bunch of these, but they're all going to do the exact same thing. You're all going to stick the numbers in the quadratic formula, and you'll have a lot of times negatives underneath the square root. Let's just do one more for that whole page. Let's do the last one. H is in hamburger. You're going to put that in the quadratic formula and find the solution. So, wait a minute though. That one doesn't have a b. Well, therefore, b is what? B is 0. So that makes it just that much easier to do the quadratic formula because you stick zeros in a couple spots. All right. And then this last section, I only want you to do D on this one. All it is foiling it out, and then what happens when you stumble across an I squared in your answer? Change it to -1. So just do D on this one. Melissa, what did you want to know? Okay, D on that page, and H on this page. And also on the upper page, we had done A and B, but B you didn't have to do the solutions, just the graph. Okay, all right, that's all we have for that one. I'm going to pause while we open up the next worksheet. Okay, so the next one's called higher degree polynomials. And basically, this is where we started learning about how things can have curves in them, like this. And when they had turns, then all of a sudden we had like x to the third and x to the fourth in our equations. But a lot of these things were easy, just like how does the end behavior. So let's look at this graph. What's the left end of this graph versus the right? And all you'd say is the left end is up or down, and the right end is up or down. So, really easy. What's the left end? Up. Right end is down. Do you remember then that that's odd? So it's got to be, nope. Not this, just wait. Not because they're different than each other. One's up, one's down. You remember how that means it's like x to the third or x to the fifth or x to the seventh? But since it's going down on the right, what does that mean? Negative in front. So let me show you a few, and you tell me whether they're, like what you know about them. I know it's been a while, but you'll catch on quick again. So this one, it's down on both ends. Even exponent. So like it could be to y equals x to the fourth for, ooh, I made my x really weird. X to the fourth. But that couldn't be right because I something else. It's got to be a negative because it's down on the right. Does that ring a bell? Okay, good. So what about this? It's got 1, 2, 3 turns in it, and it's degree 4. Does that make sense to you? Yes, it's always one different like that. So like, here's a really simple one you've known for a long time. A parabola, what degree is it? X squared. And does this one have a negative or not? No, and it's only got one turn in it. Does that make sense? Degree 2. So if it's degree 2, it only have one turn. What if it was degree 8? How many turns? 7. All right. So how about if, let's go back to the worksheet here, not get too far off of that. So let's do number 1. Each part of this will remind you about something. So I'll do this one with you. State each root and what type it is. Roots? What the heck are those? The roots are the names for 4 things. What's the important one for this? The roots are the same as the x-intercepts. The zeros, yes, but the x-intercepts on the graph, those are the x-intercepts. So now I know the roots. That root is at what? At 0. This is at 0. And is it a bounce? Is it a cut through? Or is it a snake? It's a cut through. That means it's degree 1. Remember the bouncy kind are degree 2. Okay. So this equation, it says write an equation for it. Oh, and the leading coefficient. Wait, one thing at a time. We have at 0, it's a cut through. at, what's the other root? 3. Positive 3. At positive 3, it is a, what? Bounce. And yes, that's a double.
What's a single bounce?
There's no such thing as a single bounce. A double is a bounce. A single is a cut. What's a triple? A snake. That's the one that kind of looked like that. Okay. So, is the leading coefficient negative? It's going down on the right. Yep. Negative. Okay. Write an equation for the graph in factored form. So you go y equals negative. Easy to forget, but let's put it in now. And then each of those gets its own root. What was the root for the first one? 0. So I could just say x or x plus 0 if you want to use training wheels. And then there's the 3, and it's is it x minus 3 or x plus 3? Minus 3, because when you put 3 in it, that's going to solve it and make it 0. All right, cool. There. Now, is that the correct degree? Oh, so what do I also need? A squared on this. Because now I have a 2 there and a 1 there makes a degree 3, and that makes more sense. Otherwise, it was going to be a degree 2. And for this graph, degree 2 wouldn't make sense because it's going opposite directions on each end. So therefore, I knew it had to be odd. That would have been a hint. Also, just knowing that it bounces here means that's a 2. That's also called the multiplicity. If you're the type that likes to take notes, that's a multiplicity in case they ask you that. Multiplicity is this little power right there. Okay. Write an equation for the graph in general form. To get general form, generally, you just multiply it out. Very good. And x to the 1 is just x. So that's simple. There's a minus in front of it. But then I got to do this, x minus 3 squared. I know, I'll take a shortcut. X squared and 3 squared. X squared minus 9, right?
No.
Can't do that. Why? Because you have to actually FOIL it out. Remember? All right, so once you get that all multiplied out, you're going to multiply everything by negative x. So I'd start with this part because you know how to FOIL easily. Then you'd multiply everything by negative x. What's the degree? I think we figured out it was degree 3, right? 2 for this, 1 for that. That's degree 3. If I multiply it all the way out, I have an x to the 3rd in it. That's another way to see it's degree 3. End behavior, all you have to say is up or down. That should be super simple. Ooh, increasing in maximums and that kind of stuff. All right. That is a local what? Maximum. What's this one? Local minimum. Good. Does this graph have a ultimate maximum? No, it keeps going forever. And also same for a local minimum, or sorry, an ultimate or absolute minimum. It goes down forever. So therefore, I don't know what its minimum is. But its local minimum is here, and its local maximum is there. It does not have absolute maxes or mins. All right, so, and if they ask, like state the, you can just show the points, like that's a point where there is a local max. What point is that? What comma what? 3 comma 0. Okay, so I think you should do one more like that for yourself for practice. So you should do number 2, which is right here. Same exact kind of questions. Okay? Then number 3 would kind of be like overkill, and it's got a flaw in it. What key point did they not label on problem 3? The y-intercept is not labeled. True, except I can count it. 1, 2, 3. That's at 3. But what's the other really important thing isn't labeled?
Where it crosses the x.
Right there. Yeah, they didn't label that. So we're not doing problem 3 because that's a flawed question anyway. Okay. Do you get how easy these points will be? Not everything in the final is hard. Like this. Is it? Here's left, here's right. I bet you everybody in the room can do this one. If you think about what degree it is, and you think about how it's positive or negative in front, would you please answer? Start with the right side, because that's the one that's easiest. And once you know the right side, then you'll just decide, should I make it the same as that or different than that? Everybody try this one, and I'd like you to check with the person near you and see if you get the same left and right side. And things are answers are like down, up, or up, down, or down, down, or up, up. All right, I'm going to pause for a second. Let me try that. Okay, so here we go. On A, do you get that I should check for the negative sign in front because that tells me the right side? That's what I would do first right away is what's the lead coefficient? Which one's the biggest? Biggest one wins. That one's biggest. And therefore, it's only the 2 that I have to check for being negative. So, is that 2 negative? No, it's positive. And therefore, it's up on the right. Then the other part you decide based on if this is even, then it's the same. If that had been odd, it would be different. You've probably seen people or dogs that are odd, like, holy cow, that thing's really long and skinny, that's odd. If it's different, you know, like I said in Minnesota, sometimes we say, well, that's different. Anyway, that different means odd, all right? So if it's odd, you will get different up-downs. All right, so in this case, since it's positive in front, it's up here, and since this is a 4, it's the same, and therefore up, up, up is the right answer. Raise your hand if you had that one right. Okay, good. Try the next one without my help. You should be able to fly through part B. So which side do we start on? Right or left? Right side. And if we start on the right side, we need to know, is it negative or not? So, yep, you can do this. It's negative. Which one is it? First, second, or third one? The first one. And it's because this degree is 9. So it's negative in front, so therefore what? Right is down. If the right is down, now we have to decide, is it the same as that or different than that? What is it? It's different because it's odd. That's odd. Well, that's different. It's up then. Up, down is your final answer. Raise your hand if you had that one right. Okay, good. Enough on that. So let's move on. What if it's got them written as factors like this? Like here for E. What is the degree on E as an elephant?
4.
Degree 4. You got to think if it was multiplied out like this other one was, if it was multiplied out, you'd have a degree 3 for this, and a degree 1 for that would make a degree 4. Okay? So then, it's negative in front. So then, down on the right. Anyway, why don't you try, I'll do this one. It's down on the right, on the left. Is it the same or different? Same, because it's degree 4. And that's an even number, and that's the same. So the same as down, and therefore down. Okay, why don't you do this last one? Do one that's in factored form at least, and then we're done with that worksheet. And let's move on. For D, I see a 13. If there was an x in front of it or something, then we'd have to multiply another x times that, and it would be 14. But it's just the power. There's only one power, so it's 13. So it's odd, and therefore they're different. I'll tell you that much. I just don't know. I'll let you figure out whether they're both down or both up. Anyway, do E and do F on this page. Are you with me so far? Okay, let's just do one more worksheet here, and that'll be enough for today. And then just so you know, I am going to record another video that finishes the whole thing. Gives you one last hour's worth of, I'm not going to have the video play the whole hour, but it'll be, you know, I'll try to keep it for sure less than 45 minutes of class, because that's all the class time you have on Tuesday. But I'll record one more video after school today that the teacher will play for you on Tuesday. Okay? So we won't cover everything today, but we'll get through nearly the end. Okay. So that's higher degree polys. And now we have these two things left. That and this. Rational functions and factoring higher degree polynomials. So I'm going to get through a little bit of rationals right now. Yay, there's only one worksheet. And then just let me take a quick look for next time. There's only one worksheet in there too. All right, so you know what? If we do 2 today, then I can assign 2 on Tuesday, right? Okay, so then I will stop right now, and I will cover those other 2 on my video that I record later today, and you will watch on Tuesday when you come back for your last day of review. Okay, so that's it for today. You covered 2 worksheets, and I showed you which problems to do on those 2 worksheets, and I will do the other videos or record the other ones in a video that I record later today, and you'll watch that on Tuesday. Do you understand that?
No, I understand that.
Okay. Ah, gotcha. I think it makes most sense because we've already covered 2 for today, and then that leaves 2 for Tuesday. So, all right. I'll try to do a good job on that video for you. All right, that's all I have for the video for today.